Hey, one! Greetings and welcome, friends. Mr. Wada here, my algebra buddies. Man, last night's quest was a doozy. Woohoo! It was about, like, word problems and y equals mx plus b. But maybe it wasn't even y. Maybe it was, like, some function h of t or something like that. But either way, it was mx plus b. Let's take a look at this problem together. Here's question 33. 33. It says, a linear function f models a relationship in which the dependent variable is y, decreases 4 units for every 2 units. That sounds like slope decreases. What kind of slope decreases? It's going to be going negative, right? Negative slope. And the independent variable is x. All right, so my slope is going to go, it sounds like down 4 over 2, which is weird. They could have reduced that to down 2 over 1, but that's fine. And then it tells me this little fact. It says the value of the function at 0 is -2. So that's like they told me this point, and I'm writing it in red because you guys all know what I'm doing here. 0, -2, when x was 0, the output was -2. That sounds like b equals -2. Y-intercept. Yeah, I think so. So let's see. And yeah, the m is -4 over 2, or I also could have written that as -2. So let's graph this. So I begin at the b, -2, and I'm going to move by my slope, which is either down 4 over 2 or down 2 over 1. I'll go down 2 over 1, down 1, down 2 over 1. And let's draw that line. Roll that beautiful bean footage right there. Oh, yeah. Oh, yeah. Oh, man, it's amazing stuff. Ah, that's a good idea. Yeah, have some sort of straight edge or a note card. And yeah, we'll put some arrows on the end of that. So interpreting this language, very mathy language, this is what I end up seeing. Also, I could have thought of this function as f of x because they named the function f. So f was the output, right? X was the input. They didn't give me a name for the input, but I think x is always a good. All right, let's look at some other ones. Ooh, 37 here. Yeah, I'm glad I'm doing this one. This one's going to be tricky. Notice, where's that secret little fact for this problem? What's that buried in the snowbank? Let's dig down a little bit. Oh, it's the equation. What? Sometimes they hide little facts in the pictures or the sidelines of those problems. So look out. Keep your eyes peeled like the Waldo hunters you are, that you're always looking for these things. So let's see. Here we go. The function shows the model's depth d. So depth d, that's going to be my output, of snow on the ground during the first 9 hours of a snowstorm, where t is the time in hours. Okay. After the snowstorm begins. And so notice they have d of t instead of f of x, or right, whatever. It's all good. Make sure you guys are tracking with me. We didn't do good enough on this problem to not pay attention. So I'm going to have my function is d of t equals 1/2 t plus 6. They told me this only was true for the first 9 hours of a snowstorm. So I could actually preemptively, in terms of identifying its domain, the domain was hours, the set of all time, I guess. I usually keep writing x when I'm talking about domain, such that the time was between what hours, do you guys think? Yeah, 0 hours and 9 hours. This was talking about, how much snow was happening there. Between 0 and 9 hours. So, tell me, friends, what is the y-intercept? I like it. B equals 6. Sometimes my 6s look like B's. That's okay. Man, with the score right there, I like it. So M is equal to a half, B is equal to 6. Let's graph this. Oh, look at this convenient grid I gave you guys. You're welcome. You're welcome. So the Y-intercept is 6. I guess that's the D-intercept, isn't it? And the slope is 1 over 2, so it's going up 1. Make sure I'm counting by ones on this grid here. And over 2. So my scale's a little bit wobbly, wonky, but that's okay. Right? And I can get a few points this way. So let's draw that line. Now, notice my graph, I only have existing in quadrant 1. And technically, notice I'm stopping my graph right here. Yeah. Why did I stop my graph there? Yeah, only up to 9 hours, so that's why I didn't keep going forever. So this is what we got. I've already talked about the domain. What was the range for this graph? What were the possible D values? Depth. What was my depth chart existing for? So I'm asking, when did it exist? What Y values or D values here did it exist for? It looks like the highest it was here. Lowest it was there. And it existed everywhere in between. Well, it's definitely 5 is the lowest. But I don't know what value this is. Oh, actually, let's plug... One of the ways I could do it is let's plug in the x-coordinate here and find that. And I think it's going to be 10.5. I also could have predicted it because my slope of 1/2, up 1 over 2, up 1 over 2. Halfway between the up 1 and over 2, it's going to be half as high. It's 10.5, yeah. All right. Man, a little garbly there. That's fine. That's fine. I'm going to live with it. All right. So that was part A. Part B, interpret the slope and the D-intercept of the graph. So guys, this is about a snowstorm. What does this mean? What does M equals 1/2 mean in terms of the language of the problem? Half an inch? Yeah, so half an inch of snow falling from the sky. Now this is a rate. Your slope is always a rate. It's y over x. Almost. So it's the number of inches per hour. There we go. We got it. Nailed it. I like it. I like it. So number of inches of snow per hour. So that means it was snowing half an inch per hour. So the units for my slope is always going to be the unit of my y over the unit of the x, because slope is rise over run. So y over x, whatever those units are, inches per hour, is how I can interpret that slope. Okay, tell me, so was it like at the very beginning of the storm? Did just like 6 inches of snow just go thwump, and then it was like half inch of snow per hour after that? Like what's going on with the B equals 6 here? I think you're right. My student just said, internet friends, maybe that snow was already on the ground. I think they are correct. So there was already 6 inches of snow on the ground when the storm began. That makes more sense. Okay, so that is where it started, right? When the storm began, there was already that much snow on the ground. We're familiar with that, right? Our snow doesn't melt completely between most storms here in the fine state of Vermont. Rarely. Man, I was terrified last winter. my snow bankings almost overtook my house. Like, my snowblower couldn't even throw snow high enough off of my deck, which was already like 5 feet off the ground, and like the bankings were just getting higher and higher. And fortunately, it warmed up eventually, because I would have still been buried in my house today. True. Oh, you guys are good at this. Look at this one. We've done some of these on Desmos. Problem 50 says you commute to school by walking and by riding a bus. The graph represents your commute. So notice this is distance in miles compared to time. We're going to school. So where did I start if I'm going at 0? So my distance is from where? From home, right, because I'm going to school. So since that distance seems to be increasing, I must be walking away from home towards the school. All right. It says describe your commute in words. So let's see. So for part A, so I start at home. And then what's going on in this region of the graph? What do you think? I'm going to the bus stop. All right. So it looks like I'm walking. So I walk. How far do I walk? Walk 1/2 mile. And how long did it take me to walk that 1/2 mile? Man, with the wind. What? That's amazing. So you walk 1/2 mile in 10 minutes. All right. So that's what's going on in this zone. My distance from home is not changing, most likely represented the fact that we're waiting. How long do we wait? So from 10 minutes to 14, yeah, for 4 minutes. And then lastly, what's this? I've got a phone call, internet friends. All right, so the last part is ride bus for, you're saying 4 minutes. I like that. How far? Well, we're going from 1/2 mile to 2.5 miles. 2 miles more. Also, in terms of the slopes here, check this out. My rate when I was walking was, I went 1/2 mile over 10, right? So that's like M1 was equal to 0.5 over 10, kinda. That's a weird way to write it. And the slope when on the bus, I'll call that, well, slope while waiting, I'll call slope 2. What was the slope while I was waiting? How many miles per minute was I traveling? Yeah, 0 miles per minute, right? And then the slope while on the bus, it looks like I went up 2 miles over 4 minutes, right? So this is the same as 1 mile for 20 minutes if I doubled the top and bottom of this fraction. And this is the same as 1 mile per 2 minutes. So mile a minute. Mile per minute. Okay? And notice I was traveling faster here than I was when I was walking, because I don't know if you guys know this, but usually you can't walk faster than a bus. Oh, maybe, yeah, take advantage of them stopping. Did this bus stop during its trip to get them? But then, like, once you were on the bus, you must have been the last stop, because it just, like, cruised. All right. Well, thanks for watching, internet friends. Have a great day.